Oh, just kidding, computer. Oh, computer loves me today. We love you too. All right, so we have this going on. We had to graph our sine functions, and tomorrow we're going to learn about cosine functions. So it's not going to be too much different. But here are the parts, remember graphing the sine, that we need to figure out, because we know that from this, I look, just starting to put things in here. I know my A, my amplitude, right? My amplitude's 1 because there's a 1 in front of sine, and that's where I find my amplitude information. Then I look here and I see that right after sine, before we get into the expression with x involved, we have another 1. So I know that my b value, which in this case, the b value is our frequency. We'll figure this out in a second. Frequency is also 1. All right, let's get everything done. Let's see. So we have A, we have B, and C in this case is pi. Now this is where it gets confusing for some people, because look at our given equation for this. Our given equation. Now remember, we're going to use this, and you can have this accessible for everything. But look what we have in this expression with x minus c, x minus c. So if x minus c is the function that we're trying to see, well, what's going on here then? Because it's not minus c, it's plus pi, plus pi. So c in this case is not pi. If c was pi, then it would be x minus pi. But what is it? It's x plus pi. So this is the hardest part about this. Hardest part. This is our horizontal shift. And with this, my horizontal shift is negative pi. Wait, what? It's plus pi. Did he make a mistake? I think he's making mistakes again. What's going on? It's plus pi. The standard equation is always compared to what we have. So I look here, I know my A is in front of sine. There was nothing in front of sine, so it must be a 1. B is in front of the expression with x. That's a 1 because there's nothing here. It has to be a 1. So it's x minus c, but in our actual equation, it's x plus pi. So c must be negative pi, because if I put a negative pi in here, then I end up with what I have. A negative times a negative will give us a positive. That's the hardest part, guys, that this is negative pi, okay? So watch that with your others if you have a horizontal shift in the other problems, which I probably gave you. All right, and this is our d value. This is our midline, negative 1. Okay, and that one's pretty straightforward. It's just whatever number is out there, it's going to be that number, right? Because there's nothing else. It's plus d, so if it could be plus negative 1, it ends up being negative 1. It doesn't matter for that one. The only place that matters, where it's tricky for us, is right here. You got to pay attention, because that's going to end up being negative pi. Okay. All right. So let's go ahead and graph this. Okay, I'm going to spread this out a little bit. I'm going to go, let's go, this is pi. And we'll go 4 more, and this is 2 pi. So this is 3 pi over 2, and this is pi over 2. All right. So remember, we are graphing what's happening with the rotation through the x-axis. And then I'm going to go to make this 1, 2. Yeah, that's fine. Negative 1, negative 2. And now my graph is ready. It's at least set up now so that I can graph this. So let me get Hunter in here real quick. Wait, Hunter was here already. No, he wasn't. Okay. So we're at this stage now. We are going to always start with graphing our midline. Let's graph our midline first, because that's going to tell us where this is located. Is the whole graph shifted down? Is the whole graph shifted up? We're going to see that this is our midline at negative 1. So number 1, graph your midline. We got it. We know that the graph is going to go above and below this midline. If the midline was up at 2, it would go above and below that midline. Okay. Now that's great. Now let's go ahead and we're going to graph our horizontal shift. Okay, that's where it's going to be our starting point, because we know without any horizontal shift, it would start right here. It would start right here, and it would go up and down, then up and down. But in this case, we have a horizontal shift of negative pi. So I hope I made enough space here. Let's see, it's 4 over, this is negative pi. Okay, so instead of it starting here, I'm going to put in a couple others. Let's put in negative pi over 2. Okay. If you're wondering what for the x-axis, my x-axis is always going to have pi over 2, pi. You can tell my mistake. Noises are happening. And then 3 pi over 2, and then 2 pi. You're always going to use these, okay? So if you're not sure, in this case we had to go negative direction, but it's always going to be, these are going to be the main radians that we're looking at. Okay, so let's look. Next was to find our horizontal shift. It's number 2. Notice how they're going backwards. Number 2, so watch, instead of it starting here on the axis, we're going to go, and it's going to start right here. Okay, but we don't have enough information. We don't know how far up or how far down or anything like that. The next thing that we're supposed to find is our frequency, and we got to figure out the frequency. Now, what it's saying, remember, the frequency is saying between 0 and 2 pi, the frequency is how many times it repeats. It says that it repeats once. So we're going to find our, let me go ahead and bring this down. We're going to find our period, which is going to be 2 pi divided by the frequency, in this case 1. It's divided by the frequency. 2 pi to, bleh, 2 pi divided by 1 is 2 pi. Now all that's saying is the frequency is 1. That means it repeats once over a 2 pi range, and that's the range we're looking at. So if it repeats once, then the period, which is the length of the cycle, right? This is the cycle length, how far you go before it repeats, then the cycle length is 2 pi. Okay, so watch what I'm going to do here. I know it starts way over here, so I'm going to go ahead and make my boundary. And I know that if it's going from negative pi and it goes 2 pi for one cycle, then I'm going to go here to pi. Okay. Because the period is based on what the frequency is. The frequency said there's one repeat over a 2 pi interval. So I take 2 pi, I see how long one period is by dividing it by the frequency. 2 pi divided by 1 is 2 pi. That's how I know that it's this wide, that it takes that distance to have one cycle. Okay. So now we have to use the amplitude. We did this, number 3. Number 3 is also finding the period. That's important. Now, the amplitude is the last bit, number 4. And I'll do that in red. The amplitude is 1, and what that's saying is from the midline, we're going to go up +1. From the midline, we're going to go down -1. It's just how tall the roller coaster is. So I know that it's going to go up from the midline 1, so it's going to be right here on the axis as our top boundary point. It's going to go down 1, so it's going to be down here as our bottom boundary. But really, all I'm looking at is this part right here. This is what I'm going to graph. Okay. So we found the midline. Boom. We found the horizontal shift was negative pi, so we started a negative pi. We start over here instead of right on 0. And then I looked and I saw that the frequency was 1, so I know that it takes 2 pi to go around a whole cycle. You start to see what it's going to look like? I know my amplitude is 1 above the midline, 1 below the midline. And I know that if it starts here, it's going to end here, right? So it's going to go up, it's going to go down, it's going to come back up. I know it goes through the midline right in the middle. So those are all the 3 places where it's going to cross the midline. Then we have another point up here, and we have another point down there, right? Now we have our 3 points. Now we can go in and say, oh, I know with confidence, yes, that's it. Yep, there it is. That's our graph. And, you know, traditionally we go all the way through 2 pi. So this is where You know, when I'm doing this, I might put another. Well, I should put another one here. This is gonna be 3 pi. So I'm just gonna go ahead and make it continue. Make it continue over here. And that could go on forever, but you know, this last bit, actually, I take that back. You don't have to show that. I just wanted to show that it continues in the same spacing. Yeah. Okay, everybody in the chat, let me know on a scale from 1 to 5. How do you feel about graphing these on a scale from 1 to 5? What do you think? Nice. Anyone else want to take a feedback for me? On a scale from 1 to 5. Okay. Thanks for all those feedbacks. Yes. Oh, dang. Yeah, you need graph paper. Ugh. All right, 3.54. We're mostly 3.5 and above. Mostly 4s and 5s. That's good. All right, so while we have 10 more minutes, I can do another one of these, or we can end the video for those that aren't here. We can end it, make it shorter. But which one? Look on the homework paging. Oh, I can go to it. Let's see if this messes everything up. We'll see. All right, here are the other problems. Anyone want to see another one? I will say for number 3, it goes down first. It goes down first. See how it's -2 for number 3? Because it's -2, the amplitude is -2. So that just means it's going to go down first. That's all. All right, anybody else want to see another? Yeah, I only gave you 4 problems. Oh, man, you can get half of them done right now. Number 2, you got it. All right, let's look at number 2. I'm going to do that one right here. All right, so for number 2, you got half the problems done now. Look at that. 1/2 sine of 4 times x. There's some parts of this that are going to be a lot easier, actually. So let's let me share again to this. Hopefully it's still recording. Yeah, it's still recording. So now we're doing number 2. We're going to use the same approach as number 4. And for all these problems, same approach. So I'm just getting it ready, getting it all so I can like align it, right? So I can kind of see this is that, that's that. There's no D, there's nothing plus some number out there. So let's go through. What is A? Amplitude. A, amplitude is 1/2. B, horizontal shift. What is our horizontal shift? Oh, wait. Oh, whoops. What am I doing? Am I teaching? What's going on? B is our frequency. Just kidding. B is our frequency, and that's equal to 4. It's what's in front of the expression with x. So that's 4. We're going to leave room because we're going to find the period here. And this is a good example because the period is a little bit more complicated with this. No worries. All right, what else do we have? C, horizontal shift, 0. Nice. Because it's x plus 0. There's no other value in this expression with x, so it must just be that horizontal shift is 0. Our C value is 0. Boom. D, that's our midline. The midline is 0. Ah, we got it. All right, let's graph it. And try to make a little more room here. All right, so remember, we always put in, I go ahead and put pi and 2 pi in there first, spaced out evenly. I usually, kind of make them even numbers of grid lines so that I can go in and halfway put pi over 2, half a pi, and then 3 pi over 2, 1.5 pi's. You ate 1.5 pi's? What? I don't know where that came from. I don't know. All right, so then we're going to go, I'm going to say this is half. I'm going to say this is 1. Let's go -half. Oops. And -1. Okay. Now we're ready. Okay, let's go ahead and do it in reverse order because that's the most fun way to do things. Midline, 0. Boom, 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 boom. Midline. Perfect. Dunzos. All right, number 2. Horizontal shift is 0. That means that when it's a horizontal shift to 0, it starts right there. It starts right on the y-axis. It's not moved left or right. We didn't have to move it to the -pi or -2 pi this time. All right, so no shift, then it starts right there on the y-axis. Done. All right, now let's figure out the frequency, because the frequency is, remember, how the frequency is how many times, so number of times it repeats within 2 pi radians. Okay, the number of times it repeats. It repeats 4 times. So the period is going to be the 2 pi, and we're going to break into 4 parts. So it repeats, the period is 2 pi. It's going to repeat every 2 pi. And I realize now that I've made this kind of small, but it's just going to be, instead of like a big curve, it's going to be a little curve. Okay, it's going to be a little curve. It's more squished together because there's more frequency. The number of times it repeats is 4. So we know that we have to have 4 repeats before we even get to 2 pi. There's going to be more lines. Okay. Okay, so what I'm going to do here is 2 pi, or pi over 2 is the period length. So from here, it's going to finish by the time it even gets here. By the time it gets to pi over 2, it's already going to be done. Then it's going to repeat again. It's going to be done right there. Then it's going to repeat again. It's going to be done right there. Then it's going to repeat one more time. And we get done here. Let's see if we did this right. It's going to go 1, 2, 3, 4. Frequency is 4. It repeats 4 times by 2 pi. We're good. Okay, so I put those there. That kind of helps me map where this is going. Now, let's find the amplitude. We did this, number 3. And number 4, amplitude. So I'm going to go up, right from the midline. I'm going up positive half. I'm going down negative half. And let's put our maximum and our minimum in here. It's going to go up to this line. It's going to go down to this line. It might be like too many lines. There's too many dashes. My brain. It's okay. It's all right. So we just want to remember this, and it helps to have this, microscopic zoom that they do on this, because now I can zoom in. Ooh, beautiful. All right, so look, I know that between here and here, we get an entire repeat. You get an entire frequency, one frequency. It's gonna have an entire sine wave between here and here, right? So I know with the sine wave, there's a start and a finish, and it goes through the midline in the middle. It goes up to the max in between those 2 points, down to the minimum between those 2 points. So watch what I have. That's not perfect, but what is? All right, let's keep going all the way through this. Midway through the midline. Up at the top, down at the bottom. Up, down, up. Full cycle between here, midline, it goes to the middle, up and down. It's always spaced out evenly, guys. Okay. One full cycle between here, midline in the middle, up top, down bottom. Beautiful. Beautiful. Woo! That's gorgeous. So this would be if you were designing a wave pool for your, you like that, Alicia? Those are good, huh? If you're making a wave pool for, raging waters, and you were like, yeah, that wave for number 4, that's boring. This is like the lazy river kind of waves, right? You're like, nah, we got to knock some kids off their raft. You're like, let's make the waves like this. So it's not like it's too big. It's only half, but they're coming at you quick. And you have lifeguards, so you don't have to worry about drowning people. You're just the designer of the waves. You don't have to worry about all that other stuff. And that's the problem. I think 2 is probably the max we could do, so I'm going to stop the video. 20 minutes.